Welcome to Insight Engine Academy. In this video, we will discuss another properties of acids. In a previous video, we have discussed acids reacts with metals, right? Today, we discuss another reaction, another chemical property is the reaction of acids with the metal carbonates and metal hydrogen carbonates. Right, or metal hydrogen carbonates are also called metal bicarbonates. Now, before I start this, we must know writing chemical formula of metal carbonates and metal bicarbonates. What is carbonate generally? If I write carbonate ion is CO3 minus 2, whereas HCO3 minus 1 is called bicarbonate ion. Now, using crisscross method, we can write the formula of various metal carbonates and metal hydrogen carbonates. Now, to understand the way acids react with metal carbonates and bicarbonates, let us discuss an activity, right? As we discussed in the case of metals react with acids, here reaction of acids with metal carbonates and metal hydrogen carbonates, okay? As every activity, okay, if it comes for long answer type questions, we have to use all these side headings like aim of the experiment, materials required, procedure, precautions, observations, and finally conclusion. These side headings are compulsory while writing any experiment in case of exams, right? And also while performing this activity, what precautions are to be taken, what is a idea to conduct this experiment, we will discuss here. So for that, you see the diagram, right? There is a test tube which is fixed to a retort stand, and this mouth of the test tube is closed with a 2-hole rubber cork, and through one hole Thurstill funnel is inserted, and through another hole delivery tube is inserted, right? Now the another end of the delivery tube inserted into another test tube which is containing lime water. You can see the formula of lime water, calcium hydroxide, right? Now, let us see one by one. Aim of the experiment. What is the aim? Aim is to understand the reaction between acids and metal carbonates, acids and metal hydrogen carbonates. What materials are required? You can see all the materials required. I told you in the previous videos, materials required are divided into two types. One is a apparatus required. Second one is chemicals required. So we can divide the materials required into two, apparatus and chemicals. So here is a stand, test tube, rubber cork, Thurstill funnel, delivery tube. Okay, this another test tube. This all comes under apparatus needed, the retort stand, etc. What chemicals are needed here? You see, we need 3 types of chemicals minimum to conduct this experiment. One is a sample of acid. Our motto, our aim is to identify reaction of acids with metal carbonates and metal bicarbonates. So we need a sample of dilute acid, and here we have to use only mineral acids, because mineral acids in mineral acids we have few strong acids, and that strong dilute acids are used for this experiment. Second one, sample of metal carbonates. So sample of acid can be hydrochloric acid, can be sulfuric acid is taken. Sample of metal carbonate, it can be a sodium carbonate, it can be sodium bicarbonate is taken, sodium carbonate and bicarbonate is taken, or potassium carbonate, potassium bicarbonate is taken, right? As a, okay, the metal carbonate here we can take calcium carbonate, calcium bicarbonate, etc. are taken. Next here, one more chemical. So what are the chemicals? We need 3 chemicals here, and one more 4 chemicals are needed, right? a sample of metal carbonate or metal bicarbonate, sample of acid, and lime water. What is the color of lime water? Lime water color is it's actually a colorless. Lime water is colorless. And now these are the chemicals. Now let us see the procedure of this experiment, right? Firstly, we take sample of metal carbonate in the test tube. Then using Thistle funnel, we add some acid, dilute, it can be dilute HCl, dilute H2SO4 is added, right? If I take for example, dilute HCl is added into the test tube, and sample of metal carbonate, let me take a sodium carbonate, Na2CO3 is a formula of sodium carbonate. Now, when acid is added to metal carbonate, we see evolution of gas. Like in the earlier experiment, same, the end of the Thistle funnel is inside the surface of the liquid, acid used here, whereas the end of the delivery tube is above the level of the acid solution, right? Surface of the acid. Because so that what happens is the gases released in this experiment as a result of metal carbonate and acid, that gases can only enter into the delivery tube, and that gases enter into the test tube containing lime water, right? So here this we can divide this setup into two parts. See this delivery tube, left side of the delivery tube, this is all showing the reaction of acids with the metal carbonates, and right side setup, this test tube containing lime water, it is to identify the gas released in this experiment, right? Now let us see what precautions are taken, right? This is an important precaution. The end of the Thistle funnel should be inside the acid solution, whereas the end of the delivery tube above the surface. Then what do we observe when acid is added to metal carbonate? A colorless gases are evolved. Colorless gas evolved in this experiment, right? Now this colorless gas, there are many colorless gases, like let me write we have few gases like hydrogen gas, oxygen gas, nitrogen, carbon dioxide, sulfur dioxide, etc. There are many gases which all are colorless and odorless. So to identify the gases among all these, each gas has its own identification test. Like hydrogen has a pop sound test, right? Same way, different gases have different identification tests. So what is the gas evolved and how can we test? We'll discuss. So in observation, we see a colorless gas evolved, and the gas enter into the delivery tube, and from delivery tube it comes to test tube containing lime water. Lime water is written, its chemical name is calcium hydroxide. Its chemical formula is CaOH taken twice, CaOH taken twice, which is a colorless solution, right? And now when the released gas reacts with this calcium hydroxide, I'll write the released gas, whatever, we do not know the gas released. If this released gas when reacts with calcium hydroxide, and we see our colorless solution turns into milky white substance. Milky white substance is produced, okay, or this solution turns into milky white. The gas that turns lime water milky is, what is that gas? The gas is carbon dioxide. Now from identifying the color of the changing color of the lime water here, we can understand the released gas is colorless gas is carbon dioxide. Now we conclude. What do we conclude here is, this is important, when acid solution is added to metal carbonates, metal carbonate, it produces a salt solution plus water, right? Salt, water plus CO2, carbon dioxide. This is the observation, like conclusion made from this experiment. Now what do we do? Let us repeat the chemicals used in this experiment and repeat the same, right? Let's replace the chemicals and repeat the experiment. Instead of HCl, we can also take H2SO4, dilute sulfuric acid. Instead of sodium carbonate, this time let's take sodium bicarbonate can be taken. This is a metal hydrogen carbonate. And now the same experiment is conducted. Even in this second repetition also, what happens when acid is added with the metal hydrogen carbonate, or which is called as metal bicarbonate, when reacts with, it produces salt, water and CO2. This is also the observation, because we see same lime water, like if you replace this lime water, freshly prepared lime water, right, it again turns into milky white even when acid react with metal hydrogen carbonates. So we can conclude, when acid solution react with metal carbonates or metal hydrogen carbonates, it produce salt, water and carbon dioxide. So whenever carbonates react with acids, they produce a gas, carbon dioxide gas. Now let us write the chemical reaction involved in this experiment. Let me write a first case. What is a acid that I have taken? I have taken hydrochloric acid, which is added to sodium carbonate, Na2CO3. Then we get a salt. What is a salt? Salt is generally obtained, whatever salt obtained here, right? It's an ionic compound. It has positive ion and negative ion, and the positive ion always come from the salt, metal carbonate. The metal ion is the positive ion which come from metal carbonate or metal hydrogen carbonates, whereas the negative radical or negative ion of the acid, so this positive ion of the carbonate and negative ion of the acid, these two generally combine to form salt in this reaction. So sodium and chlorine, we know Na+1, Cl -1, both are monovalent ions. So we write NaCl, salt is NaCl, plus we know water formula H2O plus CO2, carbon dioxide, fixed formula. So the main thing is to identify the salt produced for each reaction with the different acids and different metal carbonates. Okay, now after writing it, what we have to do? We have to balance this equation. So I have 2 sodium atoms, reactant side, only 1 sodium atom, product side. So I take 2 molecules, then it contains 2 sodium atoms, right? Now it becomes 2 chlorine atoms. I'll write 2 HCl, then it becomes 2 chlorine atoms. Now let's see, chlorines are balanced, sodiums are balanced, 2 hydrogen atoms, 2 hydrogen atoms, 1 carbon, 1 carbon, 3 oxygens, 1 plus 2, 3 oxygens, it is balanced. Now if you can write the formula, physical states, solution, acid solution is aqueous solution, and metal carbonate, sodium carbonate is a solid one. NaCl and water forms aqueous solution, right? And CO2 is a gas. So gases are represented by upward arrow mark. Okay, now same way, you see, acid plus metal carbonate gives rise to salt plus water plus CO2, balanced chemical equation. Remember, whenever you write a chemical equation, make sure the equation is balanced. Now, how acids react with metal bicarbonate? I told you it gives the same products. Now let us write the same acid. Let me take, or let's replace the acid. If I take H2SO4, sulfuric acid, reacting with the sodium hydrogen carbonate, right? I already told you hydrogen carbonate formula HCO3 -1, and whereas sodium is Na+1, +1 -1 cancel, both are monovalent and form the compound NaHCO3. It's sodium bicarbonate. Okay, this sodium bicarbonate is also called baking soda. So you will get in exam commonly like, what happens when acid reacts with baking soda, right? Should know baking soda chemical name is sodium hydrogen carbonate, and its formula is NaHCO3. When acid reacts with metal hydrogen carbonates, it produces salt, water and CO2. What is a salt here? I told you, positive ion from metal bicarbonates, sodium, and negative ion of acid. So what is a negative ion? Sulfate ion. Sulfate ion produces sulfuric acid. So here SO4 minus 2 is sulfate ion. Na plus 1 is a sodium ion, and the produced salt is Na2SO4, sodium sulfate, plus what are other products? Water plus carbon dioxide. Okay, now it is time to balance this equation. We have to balance. I told you, every equation is balanced. 2 sodium atoms. There is only 1 sodium atom. I make it 2. Then it become 2 hydrogens, right? 4. 2 hydrogens. Only 2 hydrogens we have. If I write 2, then it will be 4 hydrogens. Right? 2 carbons. I'll write 2 carbons. Then 1 sulfur. 4 oxygens plus 2 3s are 6, 10 oxygens, 4 here, 2, 6 here, 2 to the 4, 10 here. This is a balanced chemical equation. And now let us write physical states. Sulfuric acid is aqua solution, NaHCO3. Baking soda is a solid, Na2SO4. Sodium sulfate and water forms aqua solution, and carbon dioxide is a gas released. Okay, so this is a common, like when you repeat this activity with sodium carbonate, sodium bicarbonate, or you can take potassium carbonate, potassium, bicarbonate, you will get the same products. Same products means the nature of products produced is same: salt, water, carbon dioxide. But when you repeat different metal carbonates and different acids, the salt that we get also differs, but water and carbon dioxide are the common products. Okay, now the very important aspect of this experiment is identification test of CO2. You'll be asked, what changes do you see during a reaction of carbon dioxide and lime water? Or you are generally asked to write all the chemical reactions involved in reaction between carbon dioxide, or in identification test of CO2 gas. So that is react with the lime water. Let us see the test of CO2 gas now. Yeah, we see one of the very important and frequently asked question in board exams. That is test of CO2 gas. And what are the different steps involving in testing the CO2 gas? Let us see. CO2 gas generally, what it does, CO2 turns lime water from colorless to milky white. This is one identification test of CO2 is generally identified by this way. Why? I told you CO2. Why to identify CO2 gas? Because it is colorless, it is odorless, it is tasteless like other gases. So we can't identify which gas is released. So that we have to conduct a identification test for each and every gas released. So in this case, CO2 gas releases, and what it turns? Lime water into milky white. What chemical change takes place generally during a CO2 reacts with lime water? Let us write whenever lime water, CaOH taken twice, it's generally called lime water, is a common name, and its chemical name is calcium hydroxide. Calcium hydroxide. This lime water, on passing CO2, carbon dioxide gas, this is aqua solution. What happened? It turns from colorless to milky white. What is that milky white substance? Is a CaCO3 plus H2O. Okay, H2O means water, we know, and this CaCO3 is called calcium carbonate. This is the milky white substance formed. What is it? This is the milky white substance. which is generally insoluble in water. Insoluble in water, right? So a colorless, this is calcium hydroxide, is a colorless one, is turned into milky white substance. Fine. Now, on passing, what are the products here? CaCO3 plus H2O. If I take this product CaCO3 plus H2O, if I pass excess CO2 through it, and we get this insoluble calcium carbonate milky white substance turns into soluble substance. Calcium carbonate becomes calcium bicarbonate, CaHCO3 taken twice. Calcium bicarbonate is produced. Okay, let's balance. Let's see, one calcium, two hydrogens, one. So we have two carbons here, one carbon. So this is a balanced equation, right? Calcium carbonate plus water gives rise to CO2. Like, on this is insoluble substance. On passing excess CO2, it becomes soluble in water. Soluble in water, right? This is more frequently asked question, right? And these are the same steps involved in whitewashing walls. Let us see, like, what are the steps, various steps involved in whitewashing walls. Now let us see steps involved in whitewashing walls, right? For this whitewashing walls, generally whenever there is an occasion, walls are coated with white solution, right? And that is called a whitewashing of walls. And what are the steps generally we do it? Involved what chemical changes involved during a whitewashing of walls? Firstly, we purchase, generally let me explain what various steps we do follow. First, we purchase a white powder, okay, from the shops, and that white powder is added to water, and when we stir, we get a solution of a white color solution, like not exactly white, it's some dull white color solution is prepared, and using brush, and that white color solution is coated to the walls of the houses. Okay, then what happens after coating, soon after when you coat the walls with this white solution, the dull white solution or little grayish color, then what happens, the walls all appears so dull, like little grayish, but you know, after a few hours, after 5 to 6 hours, you can see sometimes it takes a longer time, right? It may take 1 day even. So what happens is that dull color, the grayish color walls turns into very milky white, very bright white, shining like bright white walls. What happens, you know, in every step of this whitewashing walls, and this is one of the frequently asked questions for board exams, right? Now let us see. I told you, first what do? We purchase a white powder from the shops and we mix it with the water. So what is that white powder that we purchase? So I'll write the steps first. We first take the white powder. Then this white powder is mixed with water to get a gray light, like a grayish solution. This gray solution then applied to walls. Then we see after a day what happens. The walls turns into very bright white. So there is a connection for this process and also test of CO2 gas. There is a connection, you will understand now. What is the first one? White powder. What is that white powder? The white powder is called calcium oxide. It is called quicklime. This quicklime is added to water to get a solution of lime water. So how, let's represent this in terms of a chemical equation. Quicklime is represented by calcium oxide, CaO. Water is represented by H2O, gives rise to lime water, is represented by calcium hydroxide, CaOH taken twice. Is it balanced? 1 calcium, 1 calcium, 2 hydrogens, 2 hydrogens, 2 oxygens, because it is CaOH taken twice. What is taken twice? OH taken twice. So O is taken twice, hydrogen is also taken twice. So 2 oxygens, right? 1 oxygen here, 1 oxygen here, 2 hydrogens here, 1 calcium, 1 calcium. Calcium is not taken twice, only OH is taken twice. So it is balanced chemical equation. So what is first one? Dissolving the white powder in water to get a gray solution, right? If you add small amount of this calcium oxide to water, what happens? We get a colorless solution. But generally we add in bulk in regular practice so that it turns to grayish color. So calcium hydroxide. Now what is the next step? This solution is applied to walls and after a day it turns to milky white, right? And this lime water, then after applying to walls, it reacts with the carbon dioxide gas present in air. Lime water reacts with CO2 present in air, produces what? A bright white substance. It turns to bright white substance. And this substance is lime water. I told you, what is lime water? CaOH taken twice plus CO2 gives rise to what is a milky white or bright white substance is CaCO3, calcium carbonate, and along with calcium carbonate water is also produced. But when we whitewash walls, because of the sun heat, all the water produced here is generally evaporates. So we can't see water but we see walls turns to milky white or bright white substance. Let us balance this equation. 1 calcium, 1 calcium, 2 hydrogens, 2 hydrogens, 2 oxygens plus 2 4 oxygens. We have 3 plus 1 4, 1 carbon, 1 carbon, calcium, calcium. It is also balanced. Is it clear? So these are the 2 steps involved in whitewashing the walls. One is quicklime is dissolved in water, produce lime water. This lime water reacts with CO2 to produce bright white substance or milky white substance. So this second step, you see, this second step is also used in identification test of CO2. Only CO2 gas, carbon dioxide, can turn colorless calcium hydroxide solution into bright white substance or milky white substance. Is it clear? Now, this calcium carbonate is produced, is also called limestone. What is it called? Limestone. It is also called marble. This is the material generally used to make chalk. Chalk is generally made of this CaCO3, calcium carbonate. So this is various steps involved in whitewashing walls. Practice the equations. Whenever you listen the equations, it will be like easy, simple ones. But when you try to write your own, you feel the difficulty. So to avoid it, what you have to do, you practice once, twice, thrice, so that it will be more familiar to you, more easily. You can represent, you can write all the balanced chemical equation even in exams also, right?